In this video, we're going to do some word problems that involve quadratic functions. So let's take a look at that first one. We've got a person standing close to the edge on top of a 96-foot building, and he throws a ball vertically upward. The quadratic function h of t equals negative 16t squared plus 80t plus 96 models the ball's height above the ground, h of t in feet, t seconds after it is thrown. What is the maximum height of the ball? So here's what's happening if we draw a little sketch. You've got a 96-foot building. Okay, so let's say this is the building and it's 96 feet high, right? The person throws the ball and it goes up and then goes back down. Here's the ground. Okay. And this ball is going to travel in the shape of a parabola. So let's look at that height function. The height says h of t is equal to negative 16 t squared plus 80t plus 96. So the input variable for our function is time, right? Is t. Input variable t for time in seconds, right? And the output variable is height. So what does that mean? That means that when you put in a time, you're going to get the height of the ball at that particular time. And notice that our height function is a quadratic equation in our time. And we do have that negative 16, so a is negative, so we have a downward parabola, which is exactly what I kind of tried to sketch here, right? And it's asking us for the maximum height of the ball, the maximum height that the ball reaches. And so that's up here, isn't it? Now in the parabola, what special point is that? If you set the vertex, you are right. So really, we need to find that vertex so that we can then talk about what the maximum height of the ball is, right? So first of all, remember, and just want to remind you that the input variable is t, and that our output variable is h. Right, so if I draw a little axis here. So if we're going to find this vertex, the vertex will have coordinates t for input, h for output. So we're going to use the vertex formula, the opposite of b over 2a. But this time, that represents the time. So that's the time it takes the ball to get to the maximum height. So we have to find that first before we can find the actual height, right? Okay, so looking at my function, the opposite of b is negative 80 over 2 times a, 2 times negative 16. So what I have here, let's see, this is going to reduce. I like to do some reducing here. We've got 40 over 16, which reduces down to by 4s and reduces down by 2. So 5/2 seconds. So 2.5 seconds. Takes 2.5 seconds for the ball to get to the maximum height. Okay, but we haven't answered the question. What is the maximum height? Well, that means we need to find h. Now, when t is 2.5 seconds, so we're going to do h of 2.5. Right? This would probably be a great time to get our calculator out. So I'm going to do that here. But notice how I'm putting in the 2.5 where my t is so that I can figure out h. Okay, let's go to the calculator. Okay, so here's my calculator. I went ahead and stored the 2.5 into x and used the equation, and I got 196. So what does that mean? Well, here's my conclusion statement. After 2.5 seconds, the ball reached a maximum height of 196 feet. Okay, let's go to the next one. Okay, and part B says, how many seconds does it take until the ball hits the ground? So now we're looking for a different point, aren't we? It's not the vertex anymore in our parabola. We're looking for the ball to come all the way to here. Right? Ground, that's the ground. The ball's at the ground. And so tell me about the height of the ball if it's at the ground. Well, remember that h was the height above the ground? The ball's height above the ground is h. So h is 0. when the ball hits the ground. So we're going to take our equation and set h to 0. So we're looking for a t-intercept, aren't we? We're going to set h to 0, and we are going to solve for t. And that'll give us the time, how many seconds, right? How many seconds it takes for the ball to hit the ground. Okay, so this is a quadratic equation. We can solve it using quadratic formula. It might factor, right? Matter of fact, there is a GCF. So I'm going to go ahead and factor out, I think negative 16 goes into all of these. And so I'm actually going to divide, since I have an equation, I'm going to divide by negative 16. I'll change all those signs, right? So when I divide, every single, notice everything gets divided by negative 16 for the equation. Then here I get t squared minus 5t minus 6 equals 0. And this guy factors pretty easily, doesn't it? T minus 6, t plus 1 equals 0. So here I get t equals 6 seconds, or t equals negative 1 seconds. Wait a minute, what about that? Well, we're not going to travel back in time, right? So we cannot use this guy. So our answer is that it takes 6 seconds until the ball hits the ground. That would be your conclusion statement. It takes 6 seconds until this ball hits the ground. Next problem, very similar. Okay, so here's the next problem. And actually what I want you to do is, I want you to pause the video right here, take a look at the problem and try to solve it, and then unpause the video so that you can see the solution. Okay, pause now. So let's see how you did. So as you know, to find the maximum height of the ball, we're looking for the vertex. So you're going to first find the time it took for the ball to hit the maximum height. And that's given by t equals the opposite of b over 2a. And so I went ahead and did that here. And I got 7/4 seconds, so 1 3/4 seconds for the ball to hit its maximum height. And then we substituted the 7/4 in for t in our equation and did the math and got that the height is 81 feet. The maximum height of the ball is 81 feet, and it was reached 1.75 seconds after it was thrown. Okay, good. How many seconds does it take until the ball hits the ground? So as you know, h is 0 at the ground. So we're going to set the equation, the height equation, equal to 0. If you notice that there was a GCF of -8, you're absolutely right. So dividing by -8 is a good strategy. That gives us this equation here, 2t squared minus 7t minus 4 equals 0. 2t squared minus 7t minus 4 equals 0, which factors to 2t plus 1, t minus 4 equals 0. And then we set those factors to 0 to solve for t. Again, we cannot have a negative time, so t equals 4. So it takes the ball 4 seconds to hit the ground.